Hi, I'm Tracy Jackson, and I'm the secondary math TOSA for PUSD. And we're going to be talking about Desmos, but more importantly, like the underlayer, the computation layer, affectionately known as CL. And we're going to be focusing on connecting those components to give students feedback in real time. So today's resources can be found by typing in bit.ly/PUSD, capital C, capital L 21, and that should bring up a resource page, which we'll talk about a little bit later. In the meantime, you will want to go to teacher.desmos.com and start a new activity. So click the custom and start a new activity so that you can follow along while we go through the computation layer. You'll probably have to pause this video at times just to kind of catch up and see what's going on. That's how I learned too. So having the activity open while you're going through this is really helpful. Let's dig into some CL. So we're going to be talking about how to give students feedback on Desmos using the computation layer, or the CL. The way we give students feedback really does matter as far as what their next steps are. So this is not a great picture, but think in terms of volleyball. So if you were to hit the volleyball, and instead of seeing where it goes over the net, you were just told you were doing it wrong. So how much would that help you improve? Not so much, right? I mean, you would have to keep trying until you got it randomly correct. And so we're going to look today at two different kinds of ways to give feedback on Desmos using that computation layer. That's not the little feedback thing where you type things into students. It's actually just automated. So take a look at this video. Think about how they're different and what effect they will have on students. So here they're typing in the coordinate and they get an X. Um, it's nice that they get that, right? Because if they didn't know, if you didn't have anything in there, students wouldn't know if it was right or wrong. But it doesn't differentiate between other types of answers that might just be like they're not trying. So now take a look at this type of feedback where they type in the point and it actually shows up on the graph. So students know where they are at that point. It's very different than something like that, where they just have the X or the check. So the feedback shows students where it actually goes, just like in a volleyball game, it would show the whoever hits it where the volleyball ends up. So it gives them feedback based on what they're doing, showing it where it would go. And we can use the computation layer to do this. So we're going to be giving automated graphical feedback. And we're going to do this by looking at how to copy a table, like when students type in a table, into the graph so they can see that. We're going to talk about how they can type in an equation and see it graphed on a graph. So we're connecting those components, and also coordinate point. We're going to talk about making a slider point so students can slide it around and see where that is, copying a table from screen to screen so that your screens aren't overloaded, and copying a graph to the next screen, and also copying a sketch to the next screen. So thanks, Melissa, for this. So Melissa helped figure out how to do this with a sketch. Okay, so the first thing you want to do is go to teacher.desmos.com. Just make this so you can see everything. And then once you're there, you're going to click custom. And then you're going to click new activity and call it whatever you want to. Playing around with CL. So we're just going to use that to kind of play around with it. So the first thing we're going to look at is how to copy a table onto the graph. So we need both a graph component and we need a table component. Now, what we want to do is right now, these two don't talk to each other. So whatever you type into the table, it's not connected to the graph. You have to connect those two. You'll also notice over here on the graph, these two boxes look a little bit darker, like if you continue to add rows here. So you also might want to just look at, and this isn't the computation layer, it's just in the settings of the graph. It has a header at the top. So maybe you want to put X and Y. If you don't want that header, you can just take that away. You also can lock cells that you've filled in, and you can allow students to add rows. So it's really up to you how you want to work that. I usually leave this labeled, but you don't have to. Okay, so what we want to do is connect this table to this graph. And we want to take a source, which is going to be this table, and we want to sync it into this graph. So Desmos CL has sinks and sources. And in order to do that, you always have to label the source so that the sink, what you're syncing into, knows what you're doing. And I usually do this by slide number. So for this one, maybe I would call it either table 1 or T1. And that's how my graph is going to know how I do that. Now there's two parts of this. We can edit both the graph, the actual graph, and we can edit the CL layer. So the CL layer is what's going to take the source into there. The actual graph is going to give us a point on the graph. So let's go ahead and edit the graph first. So once you have a graph, you're going to need a point. Because we want it to label all of the points in the table. So we're just going to have PQ, and that's going to give us those variable points. So we're going to go ahead and add the slider for P and for Q. We'll go ahead and keep it at 0. You don't have to, but if you're adding animation, sometimes it's helpful to keep it at 0. Okay, and then we're going to go ahead and label it because we want them to see their points. So right now it just has the coordinates. If I wanted to label them different letters, I could do that. But right now I just have the coordinates on there. Okay, so now I have to get that PQ from the table. So in order to do that, I'm going to need the computation layer. So click done here. And then click on the computation layer, which is just these two, these little arrow things. That's going to give us the computation layer. So inside the computation layer, we need to take the list of numbers in the columns in order to be able to change them into P and Q. So we type this code called number list. And as you start to type, you can see that these come up. So this is going to be a sync. So we want this to sync in here. And we want this number list to go into P. So remember that was our P comma Q that we put in the graph. And we want to get that from table 1. And so as I start to type, these just come up. I don't have to click on them. I can keep typing, but I can if I want to. So T1, and then I want to use the column, and I want the numeric value. Okay, and I want those numeric values from column 1. All right, so then the next thing I want to do is do the same with Q. So number list, and that's my sync. And this time I want to do this for Q. And I still want to take it from table 1. And I want the column numeric values, but this time I want it from column 2. So now I have those values in there to work on it. So if I take a look at this now, let's go ahead and take it out and see what would happen without that computation layer. So if I didn't have that computation layer and I did my preview, if I type in a point, 1, 2, nothing happens. So I see this point at 0, 0. That was the one I labeled on the graph, but nothing happens. So now let's go back and have them talk to each other. So let's go back to that, and I'll just reinsert what we did before. And here, 1, 2. Oops, I forgot to go in preview. Okay, so preview shows you what students would see, and then 1, 2. And see right there, it'll plot my point on there. And then I can do 3, 4, and it will just continue to plot my points. So that table now is talking to that graph. So I've got those on there, and it's labeling them with coordinates. And again, you could label them with other letters and other things like that. Okay. Anything else in here? You can change the color of the point just by clicking on it. You can change the color. You can also change where it's labeled, like where the 0, 0 is. So you can change that using this, like maybe you want it to be above or maybe to the left, depending on what your graph looks like. Okay, so now let's go ahead and look at how an equation can be graphed on here. So we are going to need an equation, which means we need this math input. We're going to need a graph. And we're going to need a note probably, or we can type in the instructions here. So we can say type in the equation of a line. Okay, so we can just see if they know how to graph the equation of a line. And so then what we want to do right now, like if we preview it, we can see that if we type stuff in, it won't graph. Okay, so it's not just like the graphing calculator, we need to make them talk to each other. So this is going to be our source and this is going to be our sink. Okay, so in order to do that, we have to label our source. And so we can call that input, maybe math input, input. Okay, so we'll call that input 2 because we're on slide 2. And then we want to take a look at the graph part of it. So let's look at the graph part. And we want to graph a function. So I'm just going to write f of x. It's going to give you this little exclamation point. Oops. That's okay. For this one, we just have to now have an F that will work for this. And so right here, this is saying, once I get F, I'm going to go ahead and graph it. So go ahead and click done. And then you want to go into the computation layer. So this double right here, this double one right here, you want to take a look at that and just type in function. And that's our sink. Remember, we're getting that from the input and we're going to have it be named F, and we want it to be simple function. Type simple function. You can use the little thing right there if you want to. And then input 2. And then it's in the math type form. So we need the LaTeX here. Source. From the source. So so now we've got that in there and we can just click done. And then when we preview here, we can type it in. Okay, so then we can type it in and it'll talk to the graph. Now right here, can you see how you can see all the numbers on here? If you wanted that to graph it, but you didn't want the students to see all of those numbers, you could do that. And if you wanted students to write on it, because right now students can't write on it. If you're clicking on it, they won't be able to write on it. All you have to do right here is just turn it into a sketch and it'll still graph that. It'll just now be a sketch that they can draw on. Okay, now notice as I typed, it changed the graph. So like +7 -2. So it's changing as I'm doing it. And sometimes you want that, but sometimes you want it to draw after it's been submitted and slowly. And so we can show you how to do that. So here you can see you can draw. So if you're asking to label points, and when I touch it, I can't see where the coordinates are. So you may want those on there, but you may not. If you don't want them on there, you want a sketch. If you do want them on there, you want a graph. And you can go back and forth in this, this one right here. So I could go back to a graph if I wanted to. Now let's talk about how we can take this and have it be submitted. So have it kind of draw slowly like a line. So in order to do that, we need to edit, add a variable and edit the domain. So let's go ahead into the computation layer maybe first. So in here, we want a variable, we'll call it T, and we'll call it number. We want it to sink in there. T. And then we want to take the input 3 or 2, input 2. And then we want to label this time since submit. So what this does is it just takes the time since the person clicks the submit button. And so then it varies. So at first it's 1 second, and then it's 2 seconds, and then it's 3 seconds. So this is changing since they click the submit button. Okay, so now we need to edit the graph so that it kind of goes along with that. And it really depends on what your domain is on your graph, how you want to change this. So if you take a look at it, you want to restrict this domain, and you want to have X is less than, and we're going to slowly make it grow. And so since our scale is 10, 10, we're going to click 10t, so 10 times t minus 10. So notice at t equals 0, where this is, it's at -10. And we'll zoom out so that you can see that a little bit. So at time 0 seconds, it's going to be at -10. At time 1 second, it's going to be at over here at 0. So it's limiting that domain right there. Okay, and then as it continues, as it's equal to 2, you can see that that's at 10. So it's not going to take too long to graph. We can change this number right here to make it slower or faster to graph, but that's how we can show it as a drawing. So let's see what that looks like. So preview, and then the line y equals to x. Now notice it didn't graph it. If I click submit, it will then draw it. Okay. And so what that limited domain did is it started it here at -10. So you'll notice if I zoomed out the graph, it's going to still start at -10. So it's already going to be drawn all the way to -10. And then as you click submit, then it's going to continue the drawing. So you have to be careful about this with your with what your window looks like. So let's preview, and you'll see it at that -10. So it's already there, but then when I click submit, it will start graphing, and it'll go all the way up. So just as you're figuring out how you want that graph to work, keep in mind the window. Okay, so now let's do a point in a graph. And actually it's a little more complicated than this, which just seems weird because usually when we graph coordinate points, we do that first. But we're gonna need a couple of things. So we need a graph for sure. And here's our graph, or a sketch, like we can use a sketch as well. And then we need a math input. Okay, and in our math input, we want a coordinate point. So we want to name this because this is our input. Well, maybe student point 3. So that's our input. We're on slide 3. We don't really need to do any CL here unless we wanted to do the we wanted the initial text to have the parentheses in there. Right now, let's just go ahead and leave that blank. And then on our graph, we just need a point. So edit graph, let's give them an initial point to try and make. So we'll give them an initial point, just like they did in the video. And then we won't want to label that because otherwise it'll be labeled what the coordinates are. So we could label it like A or something like that if we wanted to. And again, we can click on this and move the A different places, like if it's in the way. Okay. Change the color if we like purple better. Okay, so now we want the student point. And if you ever want to know like what your graph means, they do this really well at Desmos. I don't really do this well, but they have little notes, so they'll kind of tell you what the graph is about. So student point. And then you can just kind of type in directions inside there. And you see that like in our CPM book, they'll have some directions sometimes in these lines of code. Okay, so now we want a student point, and let's call it something different than P and Q, because if we call it P and Q, it's going to take stuff we've already done and already defined. So we want this, and we want the slider. And we're not going to label it, because if we label it, it'll tell them exactly where it is, but we can if we wanted to. If you were going to do any kind of animation, which we're not going to talk about today, you would want to start this at 0, 0, so students would see it move, just kind of like you did in the example, in the Desmos example. Okay, so we should be pretty good here. Let's go ahead and click done. Now we've got to get that point. So we need to get the, we need to sync it into this graph. So right now they're not talking to each other. So we need the CL and we need the sync. So go ahead and click this. Now in this, we're going to take the ordered pair and we're going to separate it so that we can plot it. This one took a little while for me to learn because it was a little less intuitive. So student, let's call a new variable student point, and we're going to take apart the point that's entered in the input. So we're going to parse ordered pair. So we're taking the X and the Y, and we want the student point 3. So that's what we're going to use for that. And it's in that math, that LaTeX form. So we want to take that. Okay, so we're going to turn it into a numeric value. So number, we want to turn it into a number. And it's going to be number A, because that's what we used in our graph, remember. And so we want the numeric value of the student point. I capitalized it. Student point, and then we want that to be our X. So that's our X. So we want the X value to then be A. So we took the X value of we took our point, we took it apart, we took the number value of the X, and that's going to be A, which is what we defined in the graph. And then we do the same thing for Y. Number and B and numeric value and student point dot Y. Okay. And if you ever see like a little exclamation point over here, it means something happened. And always just like, it's like debugging. So figure out if you called something else that same thing. Sometimes I do that. Sometimes I write the wrong number here. Okay. So here we have our A. Maybe we should have called this something different because we have our A point. So maybe let's label this P. Okay, so now we can go ahead and take a look at this. This is our source. We're getting the point. We're taking the point apart and we're defining our values of A and B in the computation layer. And in the graph, we're plotting A and B. So preview, and we can enter our point here. And there we go. So we've got, it gives us that feedback of where that point is. It's not, and if my directions were, what are the coordinates of point P, I would see that it's obviously not there. But it's not telling me wrong. It's just telling me where that point actually went. And so gives me an opportunity to see where the point 3,1 actually put me and how far away it is from here. So there's a lot more learning on there rather than just right or wrong. Okay, so that's the connection between the graphs and the tables and the points, the input. Now we can talk about like how we can use student input from another screen to go to the next screen. So that's nice so that your screens aren't so crowded, because sometimes they get a little bit crowded. The first one we're going to talk about is the table. So we're going to talk about tables and how to copy over tables, because it's nice sometimes to give students an equation, have them make a table, and then that table be over there on the next screen in order for them to be able to graph. So the first thing we're going to want to do is have a table where students are going to input things. So maybe they're going to input, and again, remember this right here. We can decide whether we want to lock the cells or allow students to add rows. If you're allowing students to add rows here, you have to take into account how many rows they might add if you're copying over the table. So just keep that in mind there. So if you only want them to have a certain number of rows, just go ahead and put those in there initially. And if they're not able to add rows, then you don't have to worry about adding more computation layer. Now we want to talk about what this table is called, because we want this to sync to the next slide. So let's call this T4. table 4. I'm on slide 4, and then we want to copy it to the next slide. So this computation layer is just a little bit tedious. So what I usually do is I have kind of a template where I copy over the CL layer, just because it takes so long to copy over each one. So I have my new table. The X and Y, I don't need to put on there because they're going to copy over. And maybe I also want a graph component here. So I want them to graph it on there, maybe a sketch actually. I might want that to be a sketch. So they're going to sketch the points that they put on that table. Maybe I'm giving them an equation and they used the table to have some points, and now they're going to plot those points on the graph. So it's going to be the student input from table 2. And so here I want to copy over table from table 4 to here. So I don't need to title this because this is going to now be my sync. So I'm going to edit the computation layer. And then I'm going to type in, I'm going to go ahead and give this here. I'm going to do T4. So I'm going to do cell content because I want the cell content in the table and the cell content in the row 0, column 1. And I want to take that from T4's cell content in 0, 1. So I'm thinking about like how you could do this with inverse functions too, how you could kind of switch them around for students. Okay, so then, and you can keep going like on the same line, I usually do the row 0, cell content. Oh, it's not letting me copy the cell content. Cell content 1, 1. T4, and I'm getting the cell content from T4. I'm copying it over from 0, 1. So this is my new cell content. This is my old cell content. And so it's just copying over, and you just keep on doing that. Oh, here. Nope. Oops. Okay, so this should be 0, 2. Row 0, column 2. Row 0, column 2. Row 1, column 1. Row 1, column 1. Okay. And I'm not going to have you watch me do all of this because that would be really boring. T4 cell content 1, 2. Okay, so now you've copied the first 2 rows. Actually, you've just copied, here's your X and Y right here. So maybe I should do one more so you can see how that works. And then it'll show up weird in your table. So you can always tell if that's working. 2, 1, T4. And then we can just go ahead and copy this whole thing. And again, I have this in, I have these tables all written out, so I really don't go through this very often. I just kind of access that and just change the T4 on there. It just makes it a lot faster. So once you've got your table, all your table code in there, you can just copy and paste it. It's a lot easier. Okay, so let's see what it looks like. So you can see these are going to be copied. This is the XY. So this is 0, 1, 0, 2, 1, 1, 1, 2, 2, 1, 2, 2. And that's going to copy over from this. And so we're going to go over here and click preview. And you'll notice like it's only these 2 that are being copied. Like the rest of them won't be copied in there because we didn't go through the whole thing. So 2, 1, 2, 2. Let's do different numbers. Okay, so if you go next, you can see these ones were copied. and the other ones were not. Now, if you wanted to have it plot, this is a sketch tool. If you wanted to have these numbers plotted for students, you could do that same thing, like where we copied the, or we had this now be the source and the graph be the sink, just like we copied the table with P and Q. You could do that as well there. So that's how you copy a table from screen to screen. And maybe you want to do that for an equation, or maybe you want to do that for the graph. And that's just a way you can do that. Now let's talk about how to copy over a graph. So we're going to need an initial graph. Let's have a graph here. Let's see, graph. And we can do all sorts of things to graph. We can have this initial thing in there, just like that. And then maybe we want to copy over the graph. And it can be a graph that students have input things into as well. We're just going to need to title it. So let's title this graph 6. Because this is now going to be my source, and my sink is maybe I want the table for this after students have figured out an equation or graph or something like that. I just want to copy the graph over, or maybe they're going to compare it to another function. Maybe they're going to use this as their parent function, and then they're going to translate things. Okay, so over here we want another graph because we want to copy it over. And so here, on 7, we want to have a graph. So let's put graph here. And maybe we want some text or something else that they're going to talk about something, who knows. So we can put some other stuff over here, but let's just go ahead and copy the graph. So in order to do that, what we want to do is we want to take the background. Oops. Graph from the graph layer. And I think it was G6 we called it. Yep, G6. And we want it to be from the calculator. Calculator. I don't know why we do that. Calculator state, I think it just means it's the graphing calculator from there. And then we can keep the bounds the same too, which is nice because then things don't move around. So we want the bounds to be the same as the G6 bounds. Okay, now it should copy over that graph. So we can preview here, and we can have students do things with that graph too. So preview, and we can see that that comes up. It's that last one over there. And if we change this one, it would also change. So we can't see it here because we haven't put it in student mode. We haven't accessed this computation layer. But if we put it in preview, we can see that graph on there. And if you have this in sketch form, then you're able to sketch on it as well. So they could write on it and they could draw another graph. Speaking of sketch, we can also copy the sketch layer, which I didn't really know about. So Melissa Wardenberg figured out how to copy the sketch layer, which is nice because if students are sketching on something, you can actually translate their writing onto the next screen. So I've seen fancy Desmos people do this, but I didn't know we could do this fairly easily. Okay, so the way we do this is we need a sketch tool, and you can use whatever background you want. You don't have to use an editable graph. You could use even a custom image with maybe congruent triangles, and then you could copy that over to the next one. I'm just going to put a graph in here right now. And then this is now going to be our source. So we need to call this something like sketch 8 maybe, or S8. And so this is our sketch now. So we'll preview, let's see what it looks like. Looks like this. And then we want to take the student writing and copy it to the next page. So we're going to let students maybe sketch something on there and then compare it maybe on the next page. So make them do it on this page, and then the next page is to compare or maybe to shift. Okay, so the way we do that, okay, so we need another sketch. Let's do the sketch. Here's a sketch. And so we want to change the background on this sketch in the computation layer. We want the background to be from that previous sketch. So we're going to use the computation layer, and our background is going to be layered. So sketch layer. And we're going to merge sketches. Okay. And we're going to merge sketches from sketch 8 dot sketch. Okay. And then sketch 8 dot current stroke. I think that takes the student input. Parenthesis, parenthesis. Okay. Oops. Okay, there we go. And then we want the bounds to stay the same. Bounds. We want them to be sketch 9 or sketch 8 bounds. Dot bounds. Okay, so now that should copy over the sketch from 8. So let's go ahead and preview and see what that would look like. Like say they have to graph something. So they graph something. We go to next, and the sketch is over there, except for we don't have that calculators. We don't have that graph. And so what we can do here is just change the background to the same background that we had. So now let's try it. Next. And there we go. So now they've got their sketch there, and you can add other stuff on the right-hand side, have them do some translations of functions or whatever you want to have them do, but then they have that as the background and it's their work, which is kind of nice. They're able to copy that over. So there are a couple more things I want to show you. One is a time-saving CL, and then 2 other features which aren't CL but very useful in the graph. So let's take a look first at the CL, and just learned about this in the summer newsletter, although I'd heard of it before, but just really learned how to do it. And you go ahead, if you want to copy things over multiple times, this works really well. So remember we had our table that looked like this. Well, let's say we want to copy this sort of content over and over again. So we just hit enter or return however many times we want to copy it. And then we click either command or control, depending on if you have a Mac or a PC, and then hold that down and then click with your mouse. And you see this cursor is getting longer and longer. So that's going to allow us to copy this several times. So as I type this in, it's typing them into all of those rows. And then remember we had, that was 0 row first column. So we're just going to type this in. We are going to have to change that later. T4, remember, was our input or our source. Okay, so now we've got that, we can actually do this vertically as well. And so for vertically, we're going to use either the Alt key or the Option key. So Option if you have Mac, Alt if you have PC. And then we're just going to put our clicker right here, hold down the Option or Alt key, and then click and hold. And then we can backspace all at once here. And then we can change it to whatever table we have. And we could do that here too when we're talking about individual ones. We just click the Option key, hold, and then we can delete and put a 1. So we can change things all at once and multiple ones. And that's just a big time saver. So that's one. And then let's go ahead and look at, we obviously would have to change some more things in here. A couple of features on just the graph. So if we're looking at our graph, one of the things we can do is add a movable point, and that's super easy to do. Let's just say A comma B. And then we add our sliders. And then we've got a movable point. We can start it wherever we want. But then if we click done, students, when they see this, they're able to move that point around. So that's just a really easy way to add a movable point. Another thing I want to show you is a nice way to add shapes on the graph where they're connected using the table. So the way we do this is we add the graph and then edit graph, and then we insert a table. Now the table, we want to go in the order that we would draw the figure. If you don't, I'll kind of show you what that looks like. 0, let's draw a square. That's easy. 4, 0. Now, if you can imagine where this is going, like it's following those points, what it's going to look like. So it's going to start at 0, 0, then go to 0, 4, then go to 4, 0, and then 4, 4. So it's not going to quite make a graph. Let's see what it looks like when we do that. So click this. And then we want lines. So we're going to turn on the lines, and we can do dotted line. Now notice it didn't make a square, and that's because of the order of the points. We can also make it draggable if we want. So we can make this draggable so that students could drag it around, which is kind of fun. Okay, so let's go ahead and edit this again, and let's put it in the order we want to draw it. So after we go to up here to 4, 4, or to 0, 4, we want to go over to 4, 4. So we're going to change this here to a 4 and this to a 0. Now notice it doesn't connect the final one. We have to come back around. So just a 0, 0. And that way we can draw a shape on there. We can do all kinds of things with that. We can make the thickness change. We can be able to drag it around. We can change the transparency, all kinds of stuff on there. So the student view, then let's just take a look at the student view. We've got this here. We made it draggable so we can move it around, but you don't have to make it draggable. And then you can also put this in a sketch as well. As you're learning CL, know that it's okay to copy, and we as teachers are pretty good with this. So it's all right to steal like an artist. Oftentimes when you're learning to draw, you really kind of figure out like what's going on, and then you add your own little twist. So it's okay to copy Desmos art. So it is a creative process, but it also is very helpful to see what someone else has done, which the resources will really help you with that. So hopefully you enjoyed talking about and learning about Desmos. And then if you go to the resource page, you'll find a wealth of information when it comes to those resources. So if we take a look at some of the resources here, you'll have a recording of these sessions. So that will be on that resource page for both Computation Layer 1 and 2. These are all the written guides. So the CL guide was recently updated, so it's actually really helpful now. It was a little hard to read before. The CL newsletter is just the up and coming things, has tips and tricks in there. The index is really nice. It has all of the different codes that you use in the CL layer. And the CL forum is a place where you can ask questions. My favorite place actually to ask questions though is the Desmos Facebook group. They're super helpful. Like you can even put your activity out there and say, I don't know what's going on, and you'll have a bunch of people help you. So the copy like an artist part here is where you will have lots and lots of different CL examples. So if you want to use CL in a card sort, you can use it in a card sort over here. Like you just click on that, and it has all kinds of options for card sorts. The math language routines, if you want sentence starters or different kinds of things with math language routines, that's the CL that has to do with that. Some good example CLs, self-checking, commonly used CL. So all of these give you a great starting place. Desmos is also very prevalent in social media. So Twitter, you can follow Desmos, and then all of these people have a really great knowledge of CL. So it can be very helpful to follow them and see kind of what they're doing. And again, that Facebook group I talked about, the YouTube playlist, that's where I liked to start. So there's a build along by Ryan de la Garza, and he does a great job, and you sort of build along while you go through those videos. Nora Oswald learned CL and did YouTube videos at the same time, so it's slow enough that you can kind of follow along. There are some other helpful resources too that are not CL based, And those resources are like symbols, like the delta symbol, or if you need some sort of symbol, there's a place where you can copy and paste those. And then the graphing calculator. There's a lot you can do when you click the graph. There's a lot you can edit in the graph. We talked a little bit about that, movable points and shapes and things, but that graphing calculator resource guide is a good starting place as well. So I added the symbols also in an activity builder in case you wanted to add it as a collection. So that's a good place to start. These resources are here for you, and you just find those by following the bit.ly web address that was given at the beginning. So right here. So hopefully you enjoyed learning a little bit about CL and how helpful it can be to give students feedback and to engage them in thinking.